Hello AP Statistics students. In this video, we are going to look at histograms. This is our last way of displaying quantitative data. So we are going to create and compare histograms of quantitative data. So remember, one of the previous ways we had of comparing quantitative data was the dot plot. So here we have an example of a dot plot. This data and these pictures are showing us the dot plot and histogram of the duration in minutes of 220 eruptions of the Old Faithful geyser. So how long do these geysers last as Old Faithful sort of explodes? So our dot plot, hopefully that's familiar. Each data point gets a dot in the dot plot. But in a histogram, we group those dots together in bars like this. And so a few things to notice about this histogram on the right. Along the bottom, we have labeled our axis, the duration in minutes. So that's how long the eruption is going. And along the vertical axis, we have the frequency, how many, kind of like how many dots would be in that bar, okay? But as you see, the bars have a certain width this time. They're not exact values. And so we have to find the way to put all the dots in the bars in an equal way. It's called binning, B-I-N. So we're going to make the bins, and we're going to start with making ourselves a histogram here. So we've got some data here. Sales tax rates vary widely across the United States. 4 states charge no state or local sales tax: Delaware, Montana, New Hampshire, and Oregon. So if you don't like sales tax, go there. The table shows data on the average total tax rate for each of the remaining 46 states and the District of Columbia. So there should be 47 pieces of data here, I believe. And so they ask us to make a frequency histogram to display the data. Now, like all things, this is really annoying if the data is not in order. And so these numbers are all jumbled up by the state because the states are in alpha order. That's not good for the numbers, and so I already put these into Excel and then ordered them from least to greatest. That will help us a lot in making our histogram. So let's start this off. A histogram has both a y-axis and an x-axis, so we'll start there. Now we have to make some decisions, all right? Essentially, what do we want to count by? How wide do we want our bins? So I look at my numbers here. I see I'm going all the way up to like 9.5-ish. So I'd like my graph to come up to 10 probably, so it looks good. So what am I going to count by to get up to 10? Counting by ones is probably the best idea. So 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4. So we are counting by ones essentially. And so my bins, so the width of each bar in this histogram is going to be 1. Oops, 8 and 9. So in my first bin, I'm going to make a table here so I know how tall to make each bar. The first one is going to be from 0 to 1. Then the next one will be from 1 to 2, 2 to 3, 3 to 4, and you can catch on there. The only tricky part here is where do you put the ones that are exactly 1 or exactly 2 or exactly 3? So the rule we have there, this first bin will be everything from 0 all the way up to, but not including 1. So it includes the first number, but it does not include the second number. Okay, from 0, or this one will be from 1 all the way up to 1.999999999. Anything less than 2. Yes, I could use alligator symbols here. You could put like X is greater than or equal to 0, but only less than 1, non-inclusive. You could write it that way. So I'm going to count all the ones between 0 and 1. There is nothing, so that bar will be 0. How many between 1 and 2? That is just this one. So there is one piece of data in that bin. All right, from 2 to 3, nothing. From 3 to 4, still nothing. From 4 up to 5, we now again have 1. From 5 up to 6. So that includes all of these up to here, but not including the 6s. So it is all of these right here. How many are they? 1, 2, 3, 4, 5, 6. And then from 6 to 7, we have all of these, but not including the 7. So it's this bunch right here. We are binning those together. So we have 5, 10, 11, 12, 13, 14, 15. 7 to 8. All the way up to here. So 5, 6, 7, 8, 9, 10, 11. 8 to 9. All the way up to here. So 5, 6, 7, 8, 9 as well there. And the last one, 9, all the way up to 10 is 1, 2, 3, and 4. Those right there. So those are my frequencies, the number of data points in each of those intervals, and that will now help me make my y-axis and help me make my histogram. So let's see, I have to go up to 15 on this graph. So 5, 10, 15 here. So from 0 to 1, it's 0. From 1 to 2, I go up 1. So it's something like that. Then I have 0, 0 for those two bins. Between 4 and 5, I'm again up 1. And from 5 to 6, I have to go up 6. So something like that. From 6 to 7, I have to go all the way up to 15. If you have good handwriting, your bars here will be the same width. Sorry about that. From 7 to 8, we have to go to 11. So that will be about there. 8 to 9, we're up to 9. So that's down here a little bit. And 9 to 10, we are at 4. So there we have a picture of what this looks like. And now that we have a picture of this quantitative data, we can describe this distribution. So I'm hoping words are coming to your mind like a single peaked here, possibly an outlier over here. We mostly symmetric, I would say here. If I just draw a general shape over this, that looks fairly symmetric with possibly an outlier over here. You can do all of those descriptors, pretty much. We would have to do some calculating to find the mean or the median, so we could describe the center, and same thing, use the data to find the spread for the range, etc. Now, this is what we would call a frequency histogram. All right, so the actual number of data points in each one. That is the frequency histogram. Now, they didn't ask for it in this problem, but we're going to do the relative frequency histogram. So what we have to do here is we have to take all of these numbers and turn them into relative frequencies instead of frequencies. That's really easy. All you do is divide by the total to get a percent, okay? So I'm gonna bring up my calculator here. Oops. And we are gonna turn these into relative frequencies real quick. Not quite that far, please. Not quite that close. There we go. So first one, we have one data point in that one, and I do believe there were 47 pieces of data here. You could count them all if you wanted, but I'm pretty sure it's 47. So that is 2.1%. All right, and we just keep going. I know this one down here is also 2.1%. 6 divided by 47, 12.7%. 31.9. Oops, that was 11 divided by 47. 23.4. And 19. Technically 0.1, but I think we'll be all right. And 4 divided by 47 is 8.5. So now we're just going to take these numbers and turn those into a histogram. I guess these are 0, 0, and 0. Now it's complete. So let's do that. So again, our vertical axis, our horizontal axis here. This time along the bottom is going to be the same. So we're still going up to 10. 5, 1, 2, 3, 4, 6, 7, 8, 9. Now the vertical axis this time is going to be a bit different. We have to go all the way up to, let's see, 31.9% it looks like, so maybe 35%. There we can maybe count by fives, maybe 5, 10, 15, 20, 25, 30, and then 35. And now we can make our bars here. So between, there we got 0, 1, and 2, it's 2.1, so it's something like that. 0, 0, 2.1 again. Between 5 and 6, we have got 12.7. Between 6 and 31. Between 7 and 8, 23. And then 19. And then 8.5. Something like that. Now, one thing that I'm hoping you can see once I compare those two, the shape looks just about the same. As long as I drew the scales or the graphs the same actual height, the shape should be the same whether you use relative frequencies or regular frequencies. Now, I guess in my excitement, I forgot to label these. We should definitely label our axes here for each one. So again, context, context, context. Go back to what are we actually looking at here. So we are looking at sales tax rate, sales tax rate. And then over here we have our percent, and again, sales tax rate. But this time we have actual frequency on that side. All right, so that is the basic way to make a histogram. Now, at the beginning of that process, we chose the bin size. Remember, I wanted to count by ones. You don't have to count by ones. And sometimes changing the bin size can really change the picture you're given. All right, so on the left here, we have the exact same graph, the exact same histogram that we just drew right here. Tax rate percent, number of states, over there. And then they changed something. Instead of counting by ones, essentially, with a bin size of 1, they made each bin 0.5. And so hopefully you can see a difference here. The shape does look different. You might actually argue that this one is bimodal, that it has 2 peaks, not a single peak. So the bin size does matter. There are pros and cons to each one. If you have larger bin sizes, you can see overall trends very well, but you might be missing some specifics. But if you make it too specific, you then miss the general trends that are happening. Okay, so there's pluses and minuses to either one. Oftentimes you'll use technology, and you won't do this by hand, so you can flip between bin sizes relatively quickly. We will do that on the calculator eventually. All right, time for some pitfalls. Misleading graphs. Hey, look, there's a graph. It's got, bars on it. That must be a histogram. If I was an evil teacher, I would ask you to describe this distribution and tell me about the shape, the outliers, the center, and the variability. And you would say, oh, look at this. It's symmetric. It has a single peak at cat, I guess. And you might go from there. This is not a histogram. This is a bar chart, all right? A bar graph or bar chart is not a histogram. This is categorical data, not quantitative data. And if you remember, you can't take the average of a categorical variable. I can't say the average looks like cat or the median looks like cat. That would make no sense. Hopefully that would put you on the right path. But there is a big difference between categorical data and quantitative data. So we've got bar charts and we've got histograms, and never shall the two meet. All right, one more pitfall or misleading thing. So here's a great example from your book. Use percents or proportions instead of counts on the vertical axis when comparing distributions with different numbers of observations. So if you have 2 samples and they're different sizes, you don't want to use frequencies. We've had this issue come up in the past, and it comes up again here with histograms. So Mary was interested in comparing the reading levels of a biology journal and an airline magazine. She counted the number of letters in the first 400 words of an article in the journal and the first 100 words of an article in the airline magazine. Mary got lazy. Mary then used statistical software to produce the histograms shown in figure 1.12a. This figure is misleading. It compares frequencies, but the 2 samples were very different sizes, 400 and 100. So if I counted 400 words for this one, of course all these bars are going to be bigger. I've got more dots. And so these just look much bigger than this histogram. You can't really compare them. What are you doing, or what are you supposed to do? Turn it into a relative frequencies, into percents. Then it's all out of 100%. And you are now essentially comparing apples to apples. And that game was fun once. Instead of apples to oranges. And so they have that relative frequency histograms over at the right. And you can see now we can definitely compare these two. They look very similar, actually. Who would have thought that the scientific journal would kind of have the same size words as a airline magazine? Hopefully you're thinking the words skewed to the right, but still single peaked. They are both very skewed to the right. All right, some other things about histograms. What are they good for? Well, histograms are great for large data sets, all right, because you don't have to put a whole bunch of dots. You can just make a bar that represents 20, 30, 40 pieces of data, etc. Okay. Next, I want to say this again. Histograms are not bar charts. Okay. I know they both have bars. I know they're both graphs. but they are not both bar graphs. Okay, they are different. So you cannot describe shape, outliers, center, and spread for a bar chart. Remember the difference between categorical variables and quantitative variables. All right, that's really important. Another thing though, because histograms give you a range of data in each bar, you cannot tell for certain where the mean / median are just from a graph. If you remember a few questions we've done, I've asked you, hey, what's the median? And I've given you the dot plot. Well, you can count the dots and figure out where the median is. You can't do that with a histogram. You can only estimate. But you can estimate, hey, it looks like the average is about here, the median is about here. You can do that estimate, but it is an estimate. All right, that's all I got for histograms. Hopefully that made some sense. If not, ask me some questions.